AWS Certified Solutions Architect 2026 Practice Exam. Real scenarios plus smart architecture. Thinking you want to pass this exam, but books confuse you, and practice tests feel tricky? Stay here, we fix this together. You can get my complete practice test link in the description or at the first comment of this video with a discount coupon for the complete practice questions. These questions come with full explanations, which will help you get your certification on the first try. Please leave suggestions in comment section to improve my videos, and don't forget to subscribe. We learn faster when we see real problems, not random service names, and we think like builders. I will show you how I think when I read hard questions in the exam. You will learn to spot cost traps, speed traps, and design traps in questions. We train our eyes to catch wrong answers before they trick us. Train, test, we need to fix, repeat. Section 1. In this section, we learn how the 2026 exam asks real system design thinking. You will see how one choice can break cost plans or break speed goals. I will guide you so you stop guessing and start thinking clearly. We will use short logic steps so your mind stays calm during the exam. You will learn to match needs with services without blind memory use. This exam wants you to balance money, speed, and safety together. You must read each line slowly and feel the problem behind the words. When one part fails, the full system can fail fast. We learn how to stop small failures from growing into big failures. This skill helps you at work and also helps you in the exam room. We focus on systems that scale and still stay within small budgets. We also learn why some designs look good, but fail under real load. You will practice picking one best answer, not many half-good answers. Your goal is to choose what fits the case, not what sounds smart. I am here with you, and we will build this thinking step by step. 1. A company needs high-speed access for users in many countries. What should they design? Use regional services with global routing support. This keeps data close to users and reduces delay during heavy access periods. 2. A web app slows down during traffic spikes. What should you improve first? Add automatic scaling for compute services. This lets the system grow during peaks and shrink when traffic goes down. 3. A database becomes slow after moving from on-site servers. What is the likely cause? Poor instance sizing for the new workload. Small instances cannot handle peak load and cause delays for users. 4. A team moves everything as is to cloud, but costs rise fast. What went wrong? They skipped cost planning for cloud usage. Cloud needs right sizing, or waste grows fast with idle resources. 5. An app fails in one region and users lose access. What is missing? Multi-region failover design. One region failure stops access, unless another region is ready. 6. Logs are lost during crashes. What design is missing? Central logging with durable storage. Logs must live outside servers, so crashes do not delete records. 7. A system needs fast file delivery to global users. What helps most? Content delivery with edge caching. Cached files load faster from nearby points, reducing server load. 8. A startup pays for servers that stay idle often. What should they change? Use scaling based on real usage. Scaling reduces waste by matching servers to current traffic needs. 9. A batch job runs at night only. What saves the most money? Use short-lived compute for batch jobs. Pay only during job time, and stop servers after work finishes. 10. A team needs fast database reads for many users. What helps first? Add read replicas near users. Read replicas share load and lower response time for reads. 11. A service fails when one part times out. What design is missing? Timeout handling with retries. Timeouts need safe retries, so small delays do not break flows. 12. Data loss happens after a crash. What is the likely design issue? No backup plan for storage. Backups protect data when systems fail or get deleted by mistake. 13. A company needs secure access between services. What is best practice? Use private network links between services. Private links reduce exposure and protect data during transfer. 14. An app cannot handle sudden growth. What should be improved? Design for horizontal scaling early. Horizontal scaling lets systems grow by adding more workers. 15. The team picks services by name memory. What skill is missing? Scenario-based system thinking. The exam tests logic, not memory of service names. Section 2. In this section, we study migration failures and scaling pain points. You will see why moving servers alone does not fix old design issues. We will learn how poor planning causes slow systems after migration. You will also see how async work helps systems stay smooth. I will show you how exam questions hide these problems in stories. You will learn to read between lines and catch the real issue. When one layer breaks, other layers start failing fast. We fix the root cause, not just the surface problem. This habit helps you answer fast and stay confident in long exams. You and I will train this skill with real style questions. We think about traffic flow and data flow in every system. We also watch how costs rise when design is weak. You will learn how to plan growth before users flood the app. We keep designs simple so teams can fix issues fast. This is how real architects think under pressure and deadlines. 1. A company moves a database to cloud and faces slow writes. What is wrong? Storage type does not match write needs. Some storage types handle reads well, but fail under heavy writes. 2. A legacy app fails under peak load after migration. What caused this? Old scaling limits moved with the app. Lifting old limits keeps the same bottlenecks in the cloud. 3. A system needs low delay between regions. What should be used? Replication with nearest region routing. Nearby regions reduce delay and keep data closer to users. 4. A batch process blocks user requests. What should change? Move batch work to async processing. Async work runs separately and keeps user paths fast. 5. A message queue fills fast and slows the system. What is missing? Proper consumer scaling design. More consumers clear queues faster and reduce wait time. 6. A team faces sudden traffic spikes. What design helps most? Event-driven scaling for workloads. Events trigger scale fast, matching sudden demand changes. 7. Users face random delays during peak hours. What is likely missing? Load balancing across multiple services. Load balancing spreads traffic and avoids single service overload. 8. A service crashes when one part fails. What should be added? Failure isolation between components. Isolated parts fail alone and do not break the full system. 9. Data sync lags between regions. What should be improved? Tune replication settings for lower delay. Faster sync settings reduce user-facing data delay issues. 10. A team pays high network costs. What can reduce this? Place services closer to each other. Shorter paths reduce data transfer costs and delay. 11. A system needs to handle sudden message floods. What helps? Add buffering with message queues. Buffers absorb spikes and protect workers from overload. 12. A cloud app feels slow compared to on-site setup. Why? Network paths are longer now. Cloud paths add hops, so design must reduce round trips. 13. Logs are scattered across servers. What is the fix? Central log storage service. Central logs help debug faster and survive server loss. 14. A team faces frequent timeout errors. What is missing? Back-off strategy for retries. Back-off avoids hammering services during short failures. 15. A company wants safer deployments. What should they use? Gradual release strategy for updates. Gradual releases catch issues early, before full user impact. You can get my complete practice test link in the description or at the first comment of this video with a discount coupon for the complete practice questions. These questions come with full explanations, which will help you get your certification on the first try. We keep building our thinking skill, and we stop fearing long questions. You will learn how small design mistakes cause big outages later. We train our mind to catch weak designs before they fail users. I will guide you through failure points, so you answer with calm. You and I will think about safety, cost, and speed together. Train, test, we need to fix, repeat. Section 3. In this section, we learn how event-based systems fail under pressure. You will see how message flow can break whole apps during traffic bursts. We focus on keeping services alive when one part slows down. You will learn how queues protect systems from sudden floods. We will also study how retries can hurt when used without care. You must design flows that fail soft, not fail hard. This skill saves money and also saves user trust during outages. We practice reading failure stories and spotting the weak link. You will get faster at picking safe designs in exams. We will link each choice to cost control and stable performance. I stay with you here, and we train this mindset slowly. You will soon feel calm when hard questions appear. 1. A service times out when another service slows down. What is missing? Add isolation between dependent services. Isolation stops one slow service from blocking other services. 2. A function retries too fast and overloads the backend. What is needed? Add delay between retries. Delays give the backend time to recover from short failures. 3. Messages fail and are lost. What should be added? Add a dead letter queue. Failed messages are saved, so teams can review later. 4. Events pile up and workers crash. What should be improved? Increase worker scaling limits. More workers clear event floods faster during traffic spikes. 5. A service fails when traffic jumps suddenly. What design helps? Add buffering between services. Buffers smooth traffic bursts and protect back-end services. 6. One failure breaks many parts of the system. What is missing? Failure boundaries between components. Boundaries stop failures from spreading across the system. 7. A queue grows fast and slows processing. What should be done? Add more consumers for the queue. More consumers process messages faster, reducing queue size. 8. A service sends duplicate events. What should be handled? Add id checks for events. Id checks stop double processing of the same event. 9. A backend crashes under retry storms. What change helps? Limit retry attempts. Limits stop endless retries from overloading weak services. 10. Events arrive out of order. What should the system expect? Design for unordered event handling. Event systems do not promise order, so apps must handle it. 11. A message fails once and blocks the full flow. What helps? Skip failed message and continue. Skipping stops one bad message from blocking all others. 12. A function runs too long and times out often. What helps? Break work into smaller steps. Smaller steps finish faster and reduce timeout risks. 13. Logs miss failure details. What should be added? Add structured logs for errors. Clear logs help teams trace failures faster during incidents. 14. A system faces random slowdowns. What is a likely cause? Hidden dependency bottlenecks. One slow dependency can delay many requests silently. 15. A team wants safer message handling. What design helps? Use id-based processing. Id handling avoids double work when retries happen. Section 4. In this section, we learn how to control cloud costs with smart choices. You will see how cheap options can cause big risks sometimes. We compare speed gains with risk of service interruptions. You will learn how storage choices change long-term bills. We connect cost thinking with design thinking for exam success. I will show you how exam questions hide cost traps in stories. We train our eyes to see waste before it hits the bill. You will learn how to balance savings with stable performance. We keep designs simple, so teams can manage costs easily. This skill helps you pass exams, and helps you at work. We practice cost logic, so you do not guess under pressure. You and I will learn to pick safe savings paths. 1. A batch job runs at night and can stop sometimes. What saves money? Use interruptible compute for batch jobs. Batch work can restart, so cheap compute reduces total cost. 2. Storage grows fast and costs rise. What should be used? Automatic storage tiering. Old data moves to cheaper storage, reducing long-term cost. 3. A team stores logs for years. What saves cost? Move old logs to cold storage. Cold storage is cheaper for data rarely accessed. 4. A service runs all day with low use. What is better? Scale down during low traffic hours. Scaling down cuts waste when users are few. 5. A company pays for idle databases. What should they change? Pause unused databases. Pausing stops billing when databases are not needed. 6. A team uses large instances for small loads. What is wrong? Poor instance sizing choice. Big instances waste money when load stays small. 7. A job can wait but needs speed sometimes. What helps? Mix cheap and stable compute types. Mixing balances cost savings with reliable completion times. 8. A company stores many small files. What helps cost and speed? Use proper storage class for access pattern. Matching storage class to use pattern cuts cost and delay. 9. Network costs are higher between services. What helps? Place services in same region. Same region traffic costs less and moves faster. 10. A team tests rarely used systems daily. What wastes money? Always on test environments. Rare use systems should not run all the time. 11. A company wants clear cost tracking. What should be added? Tag resources by project. Tags show where money goes and help teams cut waste. 12. A system stores data forever. What is a cost risk? No data cleanup plan. Old data grows bills when not cleaned regularly. 13. A service uses high-speed storage for cold data. What is wrong? Storage tier mismatch. Fast storage is costly, and cold data does not need it. 14. A team pays for backup copies rarely used. What helps? Move backups to cheaper tiers. Backups are rarely read, so cheap tiers fit well. 15. A company faces surprise bills. What is missing? Cost alerts for usage spikes. Alerts warn teams early, before bills grow too high. Section 5. In this section, we learn how tricky answers look correct, but fail small needs. You will practice seeing missing parts in good-sounding designs. We focus on reading every word in the question slowly. You will learn how to cut wrong answers step by step. We train fast thinking, without rushing into wrong choices. This skill saves time during long exams. You and I will practice removing choices with logic. We focus on what the question really wants. This helps you avoid traps built into exam questions. We keep answers simple and match them to needs. You will soon feel confident with long scenario questions. We grow this habit and use it in every test. 1. A design meets speed needs, but fails cost limits. What should you choose? Pick the design that fits the budget limits. The exam wants balance, not only speed without cost control. 2. A design scales well, but lacks backup plans. What is wrong? It fails availability needs. Scaling alone does not protect systems during failures. 3. A design uses many services, but adds delay. What is wrong? Too many hops between services. Extra hops add delay and failure points to requests. 4. A design uses global access, but misses local failover. What is missing? Regional fallback design. Global access needs local backup paths for safety. 5. A design looks modern, but breaks under load. What failed? Load testing was missing. Without testing, hidden limits appear only during real traffic. 6. A design saves cost, but slows users badly. What is wrong? Cost savings ignored performance needs. The exam wants balance between cost and user experience. 7. A design matches all needs, but is too complex. What is the risk? Hard to maintain design. Complex systems fail more and slow down fixes. 8. A design uses one region for all users. What is missing? Global traffic routing. One region adds delay for far users. 9. A design protects data, but ignores speed. What is wrong? Over-focus on safety. Safety matters, but speed still matters for users. 10. A design fits today load, but not future growth. What failed? No growth planning. Systems must grow without full redesign later. 11. A design meets rules, but costs too much. What failed? Poor cost planning. The exam tests smart spending with safe design. 12. A design fits one case, but not others. What is missing? Flexible system design. Rigid systems break when needs change. 13. A design passes tests, but fails in real use. What failed? Real traffic modeling. Lab tests differ from real user behavior patterns. 14. A design uses latest tools, but breaks old links. What is wrong? Backward support was ignored. Old links still matter in real systems. 15. A design feels right, but misses one rule. What should you do? Follow the rule in the question. Exam rules define the best answer, not feelings. Section 6. In this section, we plan your final week before the exam day. You will learn how to use time without burning out. We keep your mind fresh and your focus strong. I will guide you on what to revise and what to skip. You and I will set a simple daily plan. This plan helps you walk into the exam calm. We review patterns, not random facts. We repeat logic steps, not service lists. We test weak areas and fix them daily. This builds steady confidence before exam day. We stay light and avoid heavy study the night before. This keeps your brain sharp during the exam. 1. You forget answers during practice. What should you change? Review mistakes after each test. Mistakes show weak areas and guide focused practice. 2. You feel tired after long study hours. What helps? Short study blocks with breaks. Breaks keep focus high and reduce mental fatigue. 3. You rush questions and make errors. What helps? Slow reading of each question. Slow reading reduces missed details in scenarios. 4. You feel stressed before tests. What helps? Do one full practice test daily. Daily tests build comfort with exam pressure. 5. You keep failing the same topic. What helps? Review that topic daily. Repeated review strengthens weak memory areas. 6. You forget key limits. what helps? Write small notes for limits. Writing helps memory stick better than reading alone. 7. You guess answers often, what helps? Use elimination logic first. Removing wrong choices increases success chance. 8. You panic on long questions, what helps? Split the story into needs. Breaking stories reveals the real system needs. 9. You lose focus during exams, what helps? Practice full-length tests. Full tests build stamina for long exams. 10. You study new topics last day, what is wrong? Late new study adds stress. New topics confuse the brain before exam time. 11. You skip review of weak areas, what fails? Weak spots remain weak. Ignoring weak spots lowers your total score. 12. You feel unsure about answers, what helps? Trust your logic steps. Logic beats memory when answers look similar. 13. You feel lost in long stories, what helps? Mark key needs while reading. Key needs guide you to the correct design choice. 14. You change answers often, what is the risk? Second-guessing correct choices. Overchanging can turn right answers into wrong ones. 15. You want calm on exam day, what helps? Sleep well before the exam. Rested mind thinks faster and makes fewer mistakes. You can get my complete practice test link in the description or at the first comment of this video with a discount coupon for the complete practice questions. These questions come with full explanations, which will help you get your certification on the first try.